Hello and welcome to Aughton Math. In this edition of Aughton Math, we're going to take on some practice problems involving graphing systems of linear equalities. I think this should be a short practice, so hold on. Here we go. All right, graphing systems, isn't this great? I love doing this. All right, so graphing systems of linear inequalities. Let's move on to a practice problem. Okay, so we're going to tell, very easy, straightforward, tell whether the ordered pair is a solution of the system, just yes or no. So what we want to do is we want to substitute in the values that they give to us for the ordered pair into whatever equation or inequality that they give to us, and then determine whether or not negative 1, 1 works or 0, 0 works, at least graphically or with the system of inequalities. So 0, 0, I just love the origin in testing to see if a particular solution is correct. So if I were to plot 0, 0, it'd be right there, and we can see that it's part of the shaded region. So I'm going to go out on a limb and say yes, yes, that ordered pair is a solution of the system. So remember, if it's a solution of the system, it's a solution of both of the linear inequalities. It's part of the shaded area, the area that's commonly shaded for both of the inequalities graphically. All right, so let's take on the second problem. I have another ordered pair, negative 1, 1, and we want to see if it's a solution of the system, which means it has to be a solution of both of the inequalities. So if I have negative 1 for x, that gives me negative 2 plus 1 for y, gives me negative 1. Negative 1 is going to be less than or equal to 0. So number 1, yes. Okay, number 2, I have negative 1 minus 1, which is equal to negative 2 greater than negative 2. Is negative 2 greater than negative 2? No, it's the same. So we're going to say no in this case. So negative 1, 1 does not represent a solution of the system. It represents a solution of this inequality, but not of this inequality. So we can't say it's a solution of the system. Now, if I were to say greater than or equal to, then I would have to change this to a yes, and I have both yeses, in which case I can say yes, that solution represents, that ordered pair represents the solution of the system. Okay, next set of questions. I think this is it. All right, we've got number 3. Number 3 is going to be y is greater than x. And let's just expand it here so you all can see what's going on. Y is greater than x. X is less than 2. So it looks like we have some vertical and horizontal lines, and y is greater than or equal to negative 2. Okay, so if we were just to change the inequalities, y is equal to x would be a line that goes to the origin. It would be from the bottom left to the upper right of the page. It looks like we got a bunch of those, so we have to figure out which one works. So y is greater than x. So if I tested a point y is greater than x, in this case, if I said 2 is greater than negative 2, that would be correct. So y is greater than x is going to have a solution that represents, or that's represented by this side of that line here. And then x is less than 2. So we've already drawn this line right here. This blue line represents y is equal to x. So we've graphed in, or we shaded in, this solution. Okay, now we're just testing this number a, or letter A, excuse me, in order to see if this works. So the next is going to be x is less than 2, or x is equal to 2, and we can see, let's make that in red. X is equal to 2 gives us a vertical line. Remember, it's a little counterintuitive. And if I were to graph that in, if x is less than 2, then I'd graph in everything on this side of the equation. It looks like a is going to be our solution, I think, so far. Okay? And so we see the commonly shaded area is this blue and red area. And then y is greater than negative 2. Let's do that in black. Here we go. And we graph everything in this. So we have a montage of colors, and you can see that the solution is going to be this area right here, which is going to be A. Okay, and I just guessed that moving into this question. Okay, so A is our solution for the first problem. Okay, so let's erase this and we're going to move on to 2. So now we have y is greater than x. Now we can see that if y is greater than x, that line that goes through the origin is going to be a dotted line. And we only have one of those. It's going to be f. Okay, so all the other lines that go through the origin, y is equal to x, are going to be solid lines. So A, B, C, all solid lines. E is not y is equal to x because the slope is not 1. In this case, you can see y is equal to x. The slope is going to be 1 plus 0. The intercept is going to be at 0. So remember our y is equal to mx plus b form. Y is equal to mx plus b. So if I have y is equal to x, then the slope is going to be 1 because we assume 1 if there's no coefficient there, plus 0. We don't state the 0 for b. We just know it's 0 if it's not there. So we know that we're going to have a slope of 1 and a y-intercept of 0, 0. So it's going to go through our origin. Slope is 1. A, B, C, and F are the only solutions that have a line that goes to the origin with a slope of 1, and F is the only one that's a dashed solution, which means the inequality is going to be greater than or less than. So I can see already that F is going to be our solution, but let's just go ahead and play around with the colors, because like I said before at the beginning of this, this is a fun, I love graphing in these colors. I love this program. So let's just go ahead and finish this off and we'll be done with this particular problem. So let's do, I think we did blue first, so we'll do blue again. So we will graph, this is going to be dotted now, right? Dotted line for y is greater than x. We test a point, we'll test a point -1, 1, -1 for x, 1 for y. 1 is greater than -1, so we know the solution is going to be on this side of the graph for the first inequality. X is greater than -3, so I have -3 as my line. Let's do red again for the second. And here's my line. And I say y, or x is greater than -3, it's going to be all these solutions if x is greater than -3. And then y is greater than -1. Now let's do that in black. And that should have been a dotted line, right, coming down here. So we're going to have another, actually y is greater than or equal to -1 is going to be a solid line this time, but x is greater than -3 gave us a dotted line. Y is greater than -1 is going to be on the upper side of that line. So if we test the point 3, 0, 3, 0, 3, 3 for y would be greater than -1. So you can see it's going to be above the line. So my solution is going to be this area right here that corresponds to all the solutions. So it's going to be F. Let's erase this just to double check that we've got this right. Let's write an F here as our answer. And then we'll stop the video and you guys can go on to do whatever you want. It looks like we got it right. Right, I hope you guys had a great time looking at all these colors and graphing solutions and these systems of inequalities. Come and join us because we got some more fun stuff. We're going to solve systems of inequalities or systems of equations in 3 variables. And that's in the next section of Math.